Good day, great tens. So today we're going to talk about trapezium and kite. These are other quadrilaterals that we need to talk about. So the definition of a trapezium is that a trapezium is a quadrilateral with one pair of opposite sides that are parallel. And then we have a remark is that a trapezium is also known as a trapezoid. That's another name for a trapezium. So these are the shapes of a trapezium. A trapezium is a quadrilateral with one pair of opposite sides that are parallel. As you can see here, we only have one pair of opposite sides that are parallel. So all these here are trapeziums. And then there's a special trapezium. This one is a special trapezoid. It's a special trapezoid or trapezium, which is called an isosceles trapezium. An isosceles trapezium is a trapezium that has the angles at the base. An isosceles trapezium is a trapezium. So this isosceles trapezium is a trapezium where the pair of sides that are not parallel. So for example, if I name A, B, C, D, so the pair of sides that are not parallel, AC and BD, are not parallel, but they are equal. So an isosceles trapezium is a trapezium where the pair of non-parallel sides are equal. So in this case, those sides are those sides are AC and BD. So AC and BD are the sides that are not parallel and they are equal. So whenever we have that condition, then we know that the trapezium is going to be what? An isosceles trapezium. And then we also have this one here. It's a right-angled trapezium. As you can see, it has 90 degrees angle. So this one is right angle right here, as you can see. Yeah, so we can see here that this one here is a right angle. It's right angled. And then this one is a normal trapezium. This one is just a normal trapezium. Yeah. And then we have a kite. What is a kite? A kite is a quadrilateral with two pairs of adjacent sides that are equal. So we have two pairs of adjacent sides that are equal. So adjacent sides are sides that share a common vertex, right? For example, if we look at side A, B, and side AD, they all share the vertex at A, right? Yeah, so we can see that we have this situation where we have B, we have A, and then we have D. So A, B, and AD are adjacent to one another because they share what? A common vertex at A. And then we also have BC and DC. So we also have the vertex here, and then we have B, we have C here, and then here we have D. the sides BC and DC are adjacent to one another because they share a common vertex at C, as we can see, right? So that's what it means when it says a kite is a quadrilateral with two pairs of adjacent sides that are equal. Now, it says that those adjacent sides, they are equal. It means you can see this side is equal to this side, and then this here is equals to this. So we have that. And then we are also then given the properties of a kite, right? The properties of a kite are that we have the diagonals between equal sides, they bisect the other diagonal, meaning they divide the other diagonal into what? Into two equal parts. So the diagonal between equal sides bisects the other diagonal. And then the diagonal that is being bisected here is diagonal BD. So the bisected diagonal is diagonal BD. So diagonal BD is the one that is bisected. And then we have one pair of opposite angles are equal. One pair of opposite angles are equal. These are the angles between the unequal sides. Yeah, the angles between the unequal sides. So the angles that they are referring to here, these are the angles. These are the pairs that they're referring to. So in this case, we actually have angle B is equals to angle D. And then the diagonal between equal sides bisect the interior angles and is an axis of symmetry. The diagonal between the equal sides bisects the interior angles and is an axis of symmetry. When it says it's an axis of symmetry, it means that it basically reflects the shape. In other words, the line creates a mirror. So the line that the diagonal we are referring to here is diagonal AC. So this is diagonal AC. As you can see, diagonal AC is a mirror because it sort of reflects the same shape on the other side, right? So if you look this side and that side, you see that this shape is the same shape, it's just that it's reflected on the other side. So the line acts as a mirror or an axis of symmetry. And then they say it bisects the angle. When it says it bisects the angle, it means that it divides the angle into two equal parts, meaning angle A is divided into two equal parts. That's why we can see those two black dots. Those two black dots, they actually mean that angle A is divided into two equal parts, and also angle C is divided into two equal parts. And then the diagonals intersect at 90 degrees. It means that the diagonals AC and BD, so diagonals AC and BD are perpendicular to one another. So they are perpendicular to one another. So that's what it means. Next. So now we're going to use the properties to sort of solve the following problems here. Now, the first problem says that use the sketch of quadrilateral ABCD to prove that the diagonals of a kite are perpendicular to each other. So in order to prove that the diagonals of a kite are perpendicular to each other, we need to show that they form 90-degree angle among one another, right? So you're gonna start by saying in triangle ADO and triangle ABO. And then after that, we're gonna say AB is equals to AD is given. And then we're gonna say angle A, angle B, AO is equals to angle DAO. It's also given. Angle BAO means that angle at A in triangle BAO, and angle DAO means that angle at A in triangle DAO. Very important to remember that. And then we also have a common side. But instead of using a common side, I'm gonna use the fact that triangle ABD is isosceles. Why is it isosceles? Because AB is equals to AD. Therefore, angle ABO is equals to angle ADO. Then reason base angles of isosceles triangle. Therefore, now we have a situation where we can say we have a side, we have an angle, and then we have an angle. Therefore, we can say triangle ADO is congruent to triangle ABO, and reason angle side. Now, because the two triangles are congruent, we can say that angle AOD is equals to angle AOB. Reason congruent triangles, because the triangles are congruent, meaning they are equal in measurement with both all their angles and their sides, right? And then after this, then we can say angle AOD plus angle AOB equals to 180. Reason angles on a straight line. Angles on a straight line, and then after that, but AOD is equals to AOB. We just proved it, right? So we can replace AOB by AOD. So we can just say AOD plus AOD is equals to 180. And AOD plus AOD is 2AOD equals to 180. And then we divide both sides by 2. and then angle AOD is equals to 90 degrees. So then we just showed that the angle here is 90 degrees. Therefore, we have proved that the diagonals of a kite are perpendicular to one another. We can see that this is the diagonal AC and diagonal BD. They form a right angle together, and that's the right angle that they form. And we can also show that this is also 90 here, because we know that the diagonals are straight lines. So we know that if it's 90 degrees there, it's going to be a 90 degree there. It's also going to be 90 degrees here. It's also going to be 90 degrees there. So we have proved that the diagonals are indeed perpendicular to one another. Now the second question says, explain why quadrilateral WXYZ, this is the quadrilateral WXYZ, is a kite. Write down all the properties of quadrilateral WXYZ. So here it's a typo, it's supposed to be WXYZ. Now let's write the properties of WXYZ, right? So we can see that XW is equals to XY, and we also see that WZ is equals to ZY. Now these are pairs of adjacent sides, and they are equal. How do we know that they are adjacent? Because we have W, we have X, we have Y. WX and XY, they both share this common vertex at X. So they X, Y, and WX are adjacent sides. They are adjacent to one another, right? And we also see that WZ and ZY are adjacent sides because they share a common vertex. You see, their sides share a common vertex. WZ is equal, and we are also given that WZ is equals to ZY. So they are adjacent sides. So, and also we see here WX is equals to XY. They are adjacent sides. And then we are asked, explain why quadrilateral WXYZ is a kite. Now, one of the properties of a kite is that the pairs of adjacent sides are equal, right? So it means that this shape satisfies that property. So this shape right here, it satisfies the adjacent side property, right? Now let's see whether there are other properties that are met. So before looking at other properties, this property that we just discovered right here, this one that we just described here, this property here, this property defines a kite. This is what defines a kite. So a kite is defined by this property. So if you have pairs of adjacent sides that are equal, then you can say that that shape is definitely a kite. So if pairs of adjacent sides are equal, that it means that the property, the shape you are dealing with, is actually a kite. So then we can conclude that this shape WXYZ is definitely a kite. So WXYZ is a kite. And then what are the properties of this shape right here? The properties of this shape, in order to find them, we can be critical and think how we can discover more properties of this shape, right? So what do we see? So we see that xy is equals to xw. It's given. We see that wz is equals to zy is given, and then xz is equals to xz. It's a common site, right? So therefore it means that triangle xwz is congruent to triangle xzy, right? Reason, side, side, side. Therefore we can conclude that angle x1 is equals to angle x2, and angle w1 is equals to angle y1, angle z1 is equals to angle z2. Then these are the properties that we needed to just include. And then the other one is that angle z1 is equals to angle z2. So these are the properties that we need to, the extra properties that we needed to list. So these are the extra properties. And the reason why these angles are equal is because of the two triangles are what? The two triangles are congruent. So remember, congruent means that the shapes are equal in measurement in all their sides and angles. So that's what it means, congruent. So then these are the properties of the shape. So the properties of the shape is a kite, and it has the following properties: that z1 is equals to z2 x1, angle x1 is equals to angle x2, and angle w1 is equals to angle w1 is equals to angle y1, right? And that pairs of adjacent sides are also equal. So this is how we show that the shape is a kite and it has its own properties, right? Yeah. So this is where we end. Next time we will do the midpoint theorem.